Good evening, everyone. Thank you for joining today's session. As usual, we'll begin with a short mind relaxation technique. Let's take a deep breath. Sit back and relax. And no matter how our day has been so far, at this very present moment, let's stay grounded. Let's feel rested. And be in peace. The key to staying grounded is accepting, full acceptance of every second as it passes by. Whether it's as per our expectations or in violation or conflict with what we wanted. We can only stay light when we go with the flow and accept the good and bad. Because all the bad, when accepted, is preparing us to become more resilient, to the bad aspects. So rather than focusing on the bad, we focus on our inner resilience to the bad. Therein lies the good for us. That's how we are able to stay light, stay grounded, feel rested, and be in peace. So let's take another deep breath in and breathe out all the stress, letting it go out of our system, completely letting it out. Just letting go. And then we can experience the lightness. As the mind is no longer caught up anywhere. So release all the negative energy within. And feel pleasant and light. This is an art of learning to let go, learning to accept, learning to stay light, learning to stay unaffected, learning to stay detached. Learning the fine balance of when and how much to attach and when to disengage and detach, all in our control. So let's take a deep breath again. Breathe out all the stress. Let it go. And be grounded in our lightness, peacefulness, pleasant state. Thank you. We'll resume the session now. Thank you.
Thank you, Sister Raki. So we begin our session today with a quick round of revision. Who wants to volunteer and do a quick recap from last week? Last week we talked about big data, the evolution of big data and platforms from on-prem to cloud. So anyone wants to just share, we can do a round table and each one of us can share just one point. That way it will help you to remember and it will refresh your memory. So instead of one person saying all the points, it'll be preferable if each of you can unmute yourself and just say even one point, one thing that you remember. That's good enough. Who wants to go first?
Yeah, I would like to add, we had
Thanks, Anita, for volunteering to go first.
yeah, we covered first the history of big data. So in that, we have checked, I mean, we had gone through cases that is data visualization, data consolidation, all these things we had stuck, I mean, checked, and then we had the semi-structured data, unstructured data.
Yeah, that's right. Anyone wants to add anything more? Let me ask you the question a different way. So, if you were a data architect and the client says, I want to implement a big data platform, would you advise them to build it on-prem or would you advise them to build it on cloud?
Yeah, Mukesh. So that depends on a couple of parameters we discussed last time. Uh,
Mm-hmm.
depends on the performance and all what we are looking for. Like if you're looking for any data which is fast and other stuff. So like an ERP system, if you're looking for in-house things, then it has to be a local will better. While if it is a spread across the globe, and then it cloud may be a better solution. So there could be multiple parameters on the performance what you're looking out, and accordingly we can take a judicial call in terms of cost versus performance and all parameters.
Yeah, then that's correct. So let me be more specific. Let's say, you're a startup company, and you just started your business 2 years back, and now you want to explore doing advanced analytics. So in that case, would you want to implement a big data platform, or would you just want to go on the cloud and use what you need to do analytics?
I think we'll be preferring, if it's a new company startup, probably we'll be preferring on the cloud just to see how the data expansion that happens, and then probably initially we'll better be on the cloud to save the cost.
Yes, that's right. The reason is because it's lower entry point or lower cost of investment, right? You're not buying your own servers and building it on-prem. You're paying as you go. So for startups, cloud works out great because as your data grows, which means you're getting more business, so you're getting more income as well. And you're spending in proportion to your income. Whereas if it's on-prem, you are investing in the servers and everything. There might be a cost benefit as well, but then if your business is not growing, then your hardware cost is depreciating. The value of the server today is, let's say, $10,000 today. Next year, its actual value is 8,000, even though you're not going to sell it, but its value fast depreciates. So in 3 years, its value is like 4,000. Now, you're not actually selling it, but on paper, you can take that depreciation as a tax write-off. Um, that's so it's usually if it's a small company, they will go for the cloud as their default choice. But again, as Dinesh was saying, it depends from company to company. They can have their own cloud strategy, and then the data strategy is influenced by what is the cloud strategy. So instead of saying, well, you should go use the cloud, I would rather ask the question, do you have a cloud strategy, right? It's a question of CapEx versus OpEx. CapEx stands for capital expenditure. OpEx stands for operational expenditure. So capital expenditure is the amount of money you are spending as a one-time cost to build an infrastructure or to pay for the licensing cost or to implement a project. That's all CapEx. And operational cost is your cost to maintain the solution. So yearly subscription licensing cost, including your cloud cost, which is like pay as you go. So you have an ongoing cost because you're renting it out. Whereas versus buying a house, you have more upfront cost, but then you don't your maintenance cost is a lot less. So you have a bigger capex and lower opex if it's on-prem. If it's on cloud, it's like, you're not buying a house, you're just renting it. So your yearly expenditure will be more, but your capital expenditure would be less. So that's one factor. But you as a data architect won't be deciding that. It is aligning and knowing and understanding what is the cloud strategy, what it is that the organization has. For example, if the organization has everything on-prem and you tell them we should do it on cloud, they won't listen to you and they will say, well, you don't understand, what it is that we have. So it's always good to understand the stack. And if they ask for a recommendation, then you have to be able to justify why you are recommending it and be able to support it and work with the appropriate resources to justify the cost of investment. So usually business will do what's called as a CBA, cost benefit analysis, saying this is the cost, and cost is total cost of ownership. It is a cost to buy the servers, it is a cost to build the servers, it is a cost to train the people to build it, and it includes all the possible cost over the span of 3 to 5 years. This is the cost for year one, this is the cost for year two, this is the cost for year three, and you will calculate the total cost. And then business will say, because I'm adding this cost, what business benefit do I get? And they'll try to quantify that business benefit into one of the business drivers. Is it helping with the brand recognition? Is it helping with better reporting, which is helping you bring in more operational efficiency? Or another key trend is it helping with data monetization? Data monetization essentially means is you're using your data to build in additional sources of revenue. So, for example, if you've got customer data and if you want to sell it to someone, you can anonymize it or pseudo anonymize it so you're not violating any data privacy laws. But if you want to make money out of that data or you want to monetize your data, then there are ways you can do that. And that's an additional source of revenue. So that is a benefit. So because you're building that cluster and now you're able to get that benefit, and that benefit can be potentially quantified into some dollar numbers or some financial figures, then you can say, okay, if I'm spending 200,000 in 3 years and my expected rate of return is 600,000. So business might say, yeah, it's good enough, or they'll say, no, I'll still get that same amount of return. What if I just rent it out and not buy it? Because, I can still monetize the data, but do I really need to buy all that servers and do the investment? Specifically, when it's a new line of product, I don't even know how many people would be buying that data or so on. So to factor for that uncertainty, cloud fits well because you're paying as you go. You know that you're not spending upfront money as an investment where you're not guaranteed a certain rate of return. Any questions so far? So we talked about what's Hive and what's HBase and it's Apache Spark and how it evolved as well. You're not supposed to expect it to know that, but if you're a senior architect, then certainly you would know that as well because uh, you've been there long enough to be able to see how technology evolves. So it's good to know, but you don't need to know every detail. But as long as you know what is Hive, Hive is a data warehousing solution which was as part of the cloud era or any big data platform that is important works. HBase is a NoSQL database. Apache Spark is more of an ETL data processing analytics engine. And nowadays on cloud, Apache Spark is Databricks. Instead of Hive, pretty much no one uses Hive now because we've got Snowflake and we've got BigQuery, GCP BigQuery, and Azure Synapse. So there are native cloud data warehousing solutions which have serverless SQL or SQL engines, which you don't need the servers as such. Okay. Mhm. So today, what I wanted to discuss was talk a little bit about metadata. Um, as we discussed, right, metadata is nothing but data about the data. The example we had was if you have a file, uh, there's information in that file. But what is the file creation date? Who created that file? When was the last file updated? Where is the file stored? What is the path for the location of that file? All that is considered metadata. Similarly, if you have data in a database, can you guess what should be the metadata? I want you to start thinking. Right, wrong doesn't matter. But what is important is that your thinking process, you're thinking, because the more you start thinking, the more you will remember it. So that's why I'm encouraging you to think. If definition of metadata is information about the data, so if my data is stored in a database, what would you consider as metadata?
Metadata, as you mentioned about the file type, the file name, who created, who modified, what's the size type, etc. Apart from that, it also contains about the contents we are keeping in that file, or what contents or what category they belong to. Are also type of metadata. Like if I have to go for something like for a industry, if I have to go to what department, accounts related data, or any customer related data, or any product related data, or a specific product specification data, or a vendor data, or what kind of data it's carrying. I think that also categorization also comes under the metadata, like if we browse a website, so there's a category of that websites, whether it is educational websites or motivational website or whatever tags it carries along with that. So all such things comes under metadata.
That's right, Dinesh. But specifically, if my data is in a database, what would be
Mhm.
metadata? Let's say I have one table which has customer information, the first name, last name, date of birth, zip code, and address. So that's the information that's stored in the table. So the first name, last name, date of birth, zip code, that is the data. What would be the metadata for data in a database?
In simple terms, if we have to say, can we say it would be an index?
Yeah, could be.
Mm,
Yeah, because we need to know what is that index in a database. So index is like equivalent to a bookmark, right? So you're saying usually the ID field is an index in a database table. So that way you can sort it based on the index, or you can make sure every row that is inserted in the database is unique, because that index column could be 1, 2, 3, 4, 5, 6, the next one 1, 2, 3, 4, 5, 7, 1, 2, 3, 5, 8, and so on. So that makes sure that every row in your database is unique, right? So that's what the index is. So if I know what that index is, definitely, yes, that is metadata as well. What else do you think would be metadata? And think from a perspective, what, how does this information help? Yes, okay, if this is index is metadata, why knowing that metadata is important, and who needs to know what is the metadata and why? I want you to think for 2 minutes and guess the answer, and then we'll get into the details.
We can say as simple, like if we are reading a book and we know the index, which page to go, same way it works for data. Like if we know what is the index, we can definitely see like who has created that file, who is the author of that file, and what data is there. So I think that would be helpful.
So I'm glad you attended, Anita. So usually metadata, it doesn't have the data like specifically, it will tell you this index, like ID is the index column, that's metadata. But which was the last index and all that, the database internally manages it. But essentially, example, it's the specific answer is if you have a table in a database, the structure of the data, that is metadata. First name, last name, date of birth, zip code. It could be first name, zip code, data, and last name, no, but that the table has a particular structure, which is what columns it has. The actual value corresponding to the first name, last name, that is the data. But the structure of the table, including the indexes, everything is, all of it is metadata. So your structure of the table or the structure of your entities, right? So today we'll cover a few new concepts. So we talked about data modeling, right? Data modeling is nothing but how is your data modeled or structured. So we talked about, in relational databases, your data is normalized. So you'll have one table for customer first name, last name, and then in city ID, country ID, and so on. Then you'll have another table for city ID and a city name. Then you'll have another table for country ID and country name. So that's an example of normalized data. But if I want to know, I don't need to know that there are three tables. I just need to know what customer information am I capturing. The customer information is first name, last name, and sort of city ID. We're capturing the city. I'm capturing the country. So that structure of that data, right? That is important to business because business wants to be able to do reporting on it. So what information can they reflect in the report? They need to know that. And if they know what is the structure of the data or what is the logical model. So the way you model the data or the way you structure the data can be split into three different layers. One of them is called conceptual data model. Second is logical data model. And the third is the physical data model. And the physical data model is what has uh, the actual table structure. And that may not be useful to business, but the logical or the conceptual data model is of importance, right? So when we are considering data model, three terms: conceptual data model, sometimes they call it as CDM. Then second is logical data model, and third is PDM, physical data model. What is conceptual data model? It's basically telling you what are the entities, conceptual data entities. For example, in this case, customer. Customer is a conceptual entity and it can have a lot of attributes, but I'm at the conceptual level, I'm at a very high level. So in that case, I don't need to know all the detailed attributes or anything. I can just put the index over there to show that customer has a relationship with the products that they are buying, and I can show that relationship. But a conceptual data model is very high level, and the purpose is simply just to show that what are the conceptual entities and how and what relationship they have amongst each other. That's simply the value for creating a conceptual data model. And it's very valuable for large organizations which have a lot of different type of data entities. And the conceptual data model, because it's at a very high level, it's not normalized in any way. It doesn't have an extensive list of all the attributes or anything. It makes it easy for anyone to understand what are the key data entities in your organization, or what are the key entities, conceptual entities, to understand the business or what your data is all about. So that's the conceptual data model. The logical data model then has more level of details, which will say, okay, what are the attributes corresponding to customer? Customer has first name, last name, date of birth, zip code, city, country. That's what is the logical structure for customer. In the physical, I will say, okay, customer is split into three tables: customer table, city table, country table. And I'll show all those relationships, but it is now a little bit more complex. Typically, now there are some jobs just for data modeler. Don't go into it because those jobs are not in demand, and those are not stable jobs, because many times organizations, they think they need a data modeler. After a few months they don't need it. So I've worked with a lot of data modelers and they're always worried about their job. In an interview they'll ask you a question, can you model the data, or do you know data modeling? And this is a default answer, works all the time. uh, don't say no, say yes. However, right, I do more conceptual and in some cases logical data modeling. Physical data model, I delegate it to the database administrator. But conceptual, yes, I've done conceptual data models. In some cases, few years back, I've done logical data model. Even though you may not have done it, but at least you know what the concept is. But the fact that you're explicitly saying that you did it few years back, which means don't expect me to, start building logical data models in 2 days and finish it off. Not going to happen. You've done it few years in the past, and typically that's something, you know, uh, you may or may not enjoy it at all doing it as well. But it's good to know what it is, how to model the data. So there are tools in which you can start modeling the data. There are data modeling tools, and you can start creating or defining a data model. One of them is Erwin, ERWIN. So Erwin Data Studio, Data Modeler, and there are other data modeling tools as such. Oracle has one. There's some open source as well. But essentially, you need to know what is a conceptual data model, what is a logical data model. You need to be able to read through a logical data model to say, okay, these are the entities, and this is how they are linked with each other, and that's it. I'll give an example of, I was working with a client and they said, well, our client is expecting us to be an expert in this domain, and they are asking us for a conceptual data model for a financial client. Uh, so in that case, you have to be upfront and say, look, I haven't worked on it, but I know the approach on how to do it. Give me some time, I'll get back to you on it, right? So you don't put yourself in undue pressure by claiming to know everything, right? You don't have to, but you have to just exhibit confidence that yes, you can. Because if you've created a conceptual data model for one domain, you can extend that same concepts and apply to the other, right? Like instead of customer, they might have a patient, or here, they would have investor. So the concepts vary, but investor also has a first name, last name. So it's not something totally out of the blue. But the way I was able to do it in a very short amount of time, because there's something called as reference reference data models. uh, Companies like IBM, Oracle, they sell these reference data models for different data domains. So, for example, if you have a retail client, uh, they will tell you all the possible conceptual data entities, and they'll give you sample logical data models as well. And you can pretty much refer to them as a reference, and you can say, okay, I think based on your business, you look at their website, you understand their business, what it is that they do, what are the core activities, and then you use that reference data model, and then you can come up with a draft of it and say, this is what my understanding is based on the limited information I have. Would like to review it with someone who really understands the business of the organization and refine it. But here's the first draft of it. And usually that's good enough. The challenge is these reference data models, they're very expensive and they're not easily available on the internet. And if they are, you have to really dig for it. In my case, I just happened to be lucky that I came across the uh, financial data model from Oracle. It was on some website, so I was able to download it and then take a look at it, and client was happy. So that was one example where I built a conceptual data model from scratch. Another example was for a gene therapy company in the medical field. It was a new startup. They were defining their business and what to do, and I was responsible for building a data strategy. And as part of that data strategy, I had to understand what is the data that they have, and then take a look at what it is that they have existing. The first thing I asked them, do you have a conceptual data model? 9 out of 10 times they'll say no. And then the next question will be, can you create one? So you have to be careful. Ask the questions for which you will be able to find the answers. Otherwise, don't ask for it. So same thing, I asked for them saying, do you have a conceptual data model? Usually say they no. They'll say, or even if they say no, say, would you like me to create one? And they'll say, absolutely, that'll be great. Right. So you understand what the business that they have, and how the data flows across the organizations, and you can create a conceptual data model. But that's the approach on how you'll create a conceptual data model. I'll try to see if I can find some conceptual data models as an example, and then we can do some case studies, or once we finish all the theoretical, then we'll take case studies, what that conceptual data model is, and how to go about creating it. Any questions so far?
No, we are good.
Okay.
I
So
I have a
yeah,
question.
yes.
Uh, so like these concepts which you just told about, the three different logical layers, sorry, three layers, and these all are the concepts which we read, like I have read in my MCA. So like uh, those concepts, these are similar in the data modeling also, right?
Yeah, it is the same thing. A data modeler, typically, so there is a dedicated job title for a data modeler. And the sole
Okay.
responsibility for the data modeler is creating conceptual data models, logical data models, and physical data models. And they'll use a tool like Irwin to design that data model, or sometimes they can use Microsoft Visio as well. But essentially, the data modeler will define what those data entities are, define the data dictionary. So data dictionary is an example of metadata, because you have these fields in the table, but what is the description for that field? what does that field mean? So that is also metadata. So if you have a table with a first name, last name, customer name, first name, last name. Now that first name is for who? So the description will say this is a first name for a customer. This is an address for this is a mailing address for the customer, or this is the billing address for the customer. So we'll give you description about that field, and all this description is in a file usually called as a data dictionary. And I'll show you some sample data dictionaries as well. But that's essentially what a data modeler would do. Very few companies have this dedicated role of data modelers, very few, and they're not stable. So that's why many times the expectation is that the data architect would be able to kind of play that role. And most of the times the organization I've been with, they don't have a data modeling team. And usually, they don't give a lot of emphasis on data modeling as such. And they'll just say, okay, database administrator or DBA, just go and create these tables. So it is not a well-defined practice as such, because the cost of investment of hiring a resource, maintaining it, having that resource do data modeling, and what benefit are you going to get? Essentially, you're going to have a good uh, structure for your data, but if it's at a cost and business does not see that value, then they'll just say, okay, do whatever you want. So most of the times, large organizations would have a dedicated data modeling team. uh, Small organizations would rarely have a data modeling team, and they would not care much about data modeling as such. So it depends. So but when I'm doing an assessment, that's one of the questions I would ask them is, do you have any data modeling team? Are you using any data modeling tool to model the data? Typically, when a new project is created, who models the data? I would ask them that question to do an assessment.
Okay, fine. Got it. Thank you.
And then there is a data governance team. So large organizations would have a data governance team, and then data modeling would be part of that data governance team. So anytime someone adds a new conceptual entity, they would ask them, where does this model reside? Can we review it to make sure it's following and adhering to the naming convention or the naming standards? Because these tools like Irwin, you can enforce a naming standard for these data models. The key point is, uh, don't if the role is 80% data modeling and rest other things, uh, I wouldn't take that role, right? Because you're not going to enjoy it, and it's the pay is not great anyway. But if the role is 80% data architect and 20% modeling, I will take it, because realistically, whoever created that job description did a cut paste from it, and there's usually not much data modeling work. And even if it is, it's at the conceptual level. And conceptual data models are very easy to create it, very easy to understand. And most of the time, they would have a logical data model in place. You can review it and provide what it is. But if it's 80% architecture, 20% modeling, go for it. But if it's 80% modeling, 20% data architecture, that's a red flag. Don't go for those jobs. They won't be stable, and they won't be paying much anyway. So from a practical perspective, you need to know what is data modeling. You need to know what is a conceptual data model. You need to know how to go about and create a conceptual data model. You need to know how to read a logical data model. You need to know that a DBA does a physical data model and not a data architect. If it's a startup, they would expect you to do everything. So that's why I work for large companies. Startups, it's too much work and the pay is not there. But again, it depends. Some organizations, some individuals like working for a startup. They like that energy, like the stock option. They like that. It gives them the thrill. So it depends, what your style is, what your comfort level is. My experience has been limited to Fortune 10 organizations. So for those organizations, they will have a data modeling team. They will use data modeling tools as well. Okay. Many times you have these when you're defining a conceptual data models. There's another term with it called data domains. And essentially, the data domain is nothing but a collection of these custom a collection of these data entities, collection of these conceptual data entities in a logical bucket called a data domain. So, for example, I can have in financial, I have payments, and the payments would have a lot of conceptual entities for payments, uh, and then they would all come under the finance category. Or, I'm basically I'm categorizing all the data models into one bucket called as the data domain. And the advantage is because when it comes to data governance is nothing but managing your data. uh, it's management of the data by the business for the business. Just like, in democracy, we say government, right? You're electing the elected professionals, right? You are giving them the power to manage all the policies and govern the society or the public. Similarly, data governance is for the business, by the business, to provide the right data at the right place at the right time. That's the definition for data governance. I'll repeat one more time because we'll cover this one more time, but I just want you to start throwing this and start memorizing what is data governance. Because many times people will talk about data governance, but they'll miss out on the key fact that data governance is by the business, for the business, and its sole purpose is for business team, business leaders to understand the data so they can take ownership of the data, right? So it is by the business for the business with the objective to provide the right data at the right place at the right time. That's all data governance is. So in a data governance team, you would have data modelers as part of that data governance team, because the role of data governance team would be saying, okay, you added a new data domain, or you're adding a new conceptual data entity. So which data domain should it go to? Who updates the diagram? So all that falls under data governance and data modeling team. So logical data models, again, you would use a tool like Irwin, and then sometimes nowadays these tools, they would create a physical data model from the tool itself. So as you know, when you're creating a physical data model, then in that case, you have what's called as a DDL or DML, data manipulation logic or data definition logic. But essentially, you can create a structure of a table in a database using a script, right? And then you can write script to insert the data, you can write script to create the table. So instead of you handcrafting and writing that script, you can use these tools in which you've modeled the data, and these tools will auto generate the DDL script for you. You can manually review to make sure it's all good, and then you can execute it to create that table in your database server. So your structure of the table, that's an example of metadata. And business needs to know and understand the structure of the table, because then they will know how to do reporting. Data governance, which has business representation, needs to understand the structure of these tables. So that way they can maintain the data dictionary and they can make sure business has ownership of this data. And IT also needs to know the structure of that data, because they need to store these data models, make sure they are up to date as well. And then they can enforce and apply data policies. So the data policy is that, for example, of a data policy is, if my table has PII, then I need to tokenize, or I need to mask the data when I store it. That's an example of a data policy. But which table should I apply that data policy to? If the table has no PII, I don't need to do anything. So how do I know which tables have PII? So at the time of creating that table, I can identify, or I know based on the name itself or by looking at the data dictionary, that this is PII. And then that's why this table would come under the purview of these data policies. Does everyone remember? I'm assuming we discussed it. You remember what is PII? Can anyone tell me what is PII?
Personal identifiable information.
Can you give me an example of PII. All, by the way, these are all interview questions as well. So think of
Yeah.
this as a mock interview. So can you give me an example of PII?
It can be, say, probably a date of birth, or maybe address, or it can be maybe a passport number, or maybe an email ID, or these kind of information, maybe an age. Yeah.
Yeah.
Even
First
mobile
name, last
number.
name.
Yeah.
Yeah, mobile number, first name, last name. Anything which can tie you back to that individual is PII. Even the IP address can be PII because it can link to who accessed what and when. Yeah. So we discussed, do you remember the Brad Pitt example in New York we discussed 2 weeks back? Does anyone remember that example?
Yes, he's the one who went to New York by taxi, and he was identified.
Exactly. He paid in cash to leave
Yeah.
no digital trace, yet he was identified. So many passengers taking taxis in New York every day, yet he was identified. Which specific taxi did he take? From which point A to point B? How much did he pay and when? So it's very interesting what data can help you identify. So that's all PII. Different countries have different attributes for PII. Japan has a very stringent requirement for what is even PII, where even your suffix or prefix is also part of PII. For example, you're saying doctor, or you're saying, miss, or you're saying junior or senior, even that is PII. So they're very specific about what is PII. Some countries they don't consider whether you're Mr. or Miss or anything. They don't care that as part of PII. Your first name, last name is definitely PII. But if you went to Japan and if you miss out on that, they'll be like, no, this is PII. So you just need to be aware of country-specific laws as well. So in this case, if this table has PII, how do I know this table has PII or not? So I need to flag it. So when to flag it? The best time to flag it is when you're creating a new table. I'll say, well, this table has PII, or this table has PCI. Does anyone remember what is PCI?
Yeah. Financial data.
Credit card information, that is PCI.
Yeah.
PCI comes under, there's a standard, PCI DSS level 3, it's a standard. And organizations, if they have any PCI data, you need to be very, very careful. And the reason is because if you are storing PCI data in an IT system or on a server or within a database or anything, as part of that PCI DSS 3 standard, every year there's an audit process. And in that, an auditor will come and take a look at who has access to what data, and what controls have you applied. Are you encrypting the data, and what security controls you have? Because as you know, there's like too much credit card fraud. And the purpose of this standard is to stem those losses, because it's a huge burden on the industry in terms of the amount of fraud that goes on with all these credit cards. So essentially, what they'll do is they will do an audit and see, you've got all those security controls applied wherever the PCI data is. These audits are very expensive, very time consuming. So usually organizations will create a separate network on which they will have PCI data, and they will not commingle it with other data sources, because if they do commingle it, then that other system also falls under the purview of PCI DSS3 compliance, and that adds to the cost and amount of effort. So it's a standard best practice that if you have PCI data, keep it separate. Don't mix it with your other normal data sources, because you will fall under that PCI audit and it'll bite you, it'll cost. So usually there are two strategies companies will do. One is either not store any PCI at all and instead contract with some third party vendor who stores the PCI data. So that's why you will see many times you're making any retail purchases. When it comes to the payment, it will redirect you to some other site, and that other site is the third party vendor through which the company is contracting. They are storing all the PCI and processing the payment and everything. And they will send an information back to the company saying, yes, this was the order ID, this was the amount. They'll give all the information and a tokenized number for the credit card or just the last four digits of credit card. But they won't send the full credit card information to the company because the company doesn't want to store it. It's too much liability. So that way they can store just the four digits of the credit card number and they'll have all the details and essentially they've got the payment. Any guess why they would still want four digits even though they don't want the full credit card number? Why would they want to store four digits of the credit card information? What importance, potential importance, the last four digits of a credit card could have to a company? So it's not the full credit card number. What value does just the four digits of a credit card number have?
Yeah,
Just tell that it's a genuine credit card may not be, it won't be identifying a particular person, but it's a genuine credit card. I mean, it's not the, is that the real one? Is
Yeah,
that what it?
so the reason is because they want to do analytics at a household level, right? So in a
Okay.
house, there's a husband, wife, and a teenage daughter, let's say. All three have credit cards, or they're using different credit cards. Uh, but it's three cards which they're using among themselves. But I want to do analytics at the household level. What is this house, this family buying? In that case, I don't care about that specific individual card, but that four digits, if I can do analytics and tie with it, I can provide a better recommendation engine and say, well, because let's say, realistically, wife wants to do shopping, she'll just tell their husband, oh, you're on the way, just get these things. Husband will say, well, I'm busy, or he'll get it next time. Next time we'll say, okay, you get it. But the amount of household items is the same. But one time it was on one credit card, the second time it was on the other credit card. But it was the same amount of purchases tied with the household level. So the credit card number varies, but there is a pattern to it. Yes, it varies, but it's varying between one among those three. So if I can find out, this order ID, give me all the transactions related with this last four digits of the credit card number. And if I can find a pattern to it, then maybe I can use that information and build a recommendation system as well, saying, it's time for you to buy this particular product. You haven't bought beer in 3 months, you will give you a 5% discount if you buy it, and so on. So even that four digits, although it is not the full number, has value because it can help you identify members of a household. Does that make sense? Okay. So don't store PCI data. If you do, store it in a separate PCI compliant system. And if you want to store it with another system, make sure you tokenize it. So you're masking it or you're tokenizing it, which means instead of a number, you're storing equivalent to an encrypted string like C dash dash exclamation mark 34 underscore exclamation mark dash dash. That's an encrypted string. That's what it looks like. So even if someone has access to that data, they are not seeing an actual number. So that values of no use to them. So then that data doesn't fall under the purview of PCI compliance because you didn't store the actual credit card number as it is. But usually organizations are very keen on making sure they segregate PCI information from non-PCI systems. PII, they will commingle it, because PI is everywhere. Because of GDPR, the data privacy law in EU, and we discussed the data privacy law in India as well, there are tools where you want to identify all the tables that have PII. So if the customer wants to invoke right to forget, where they want you to forget everything about them, then in that case, to implement the right to forget, you need to know where all the customer information is. So then you can go and purge it or soft delete it. So in that case, again, the metadata becomes very important, because if I don't know where all the customer information is, what tables it is, then how will I go and delete it? So metadata is very important, because then I'll know, okay, these are all the tables where PII is. So then I can write a single script and say, okay, for this person with this ID, go and delete all this information, or make that record invisible. So that way, I'm not pulling up that record and using that information for marketing and other reasons. Or you can just tokenize it. So that way, I don't know who that specific individual is, but I can still use that data for analytics. Okay. So another example of metadata is where you are actually changing the structure of the data when you move the data across. So we considered an example where you're creating a web form, you submit the data. Now you can submit that data to an RDBMS, or you can submit to a NoSQL database. Then that data moves from that RDBMS or NoSQL into a data warehouse or a big data platform, or to the data lake. The word which is now used instead of a big data platform is a data lake. And data lake is nothing but a reservoir where you get all the information in. So data is flowing or gravitating from your transactional system to the data lake. So you capture the information on a form, on a web port, you're taking in all the information, you hit submit, it takes all that information, puts in a database, and then at night, that information goes to a data warehouse. That's the old way it was done. Nowadays, instead of doing it at night, it's change data feed, or it uses what's called as CDC, change data capture. As and when that record is inserted, it will trigger a change and it will send it to the data lake. Yeah, and on the data lake, it could go to a NoSQL database, or it could go to a object storage, which is the Azure Blob, or it could go into an or cloud data warehouse like Snowflake as such. So your data is moving. Now, when your data is moving from the transactional system where you put that data in the database, and it's moving to a data warehouse, the structure of your data is going to change. The structure of the data, for example, in that transaction system was first name, last name, date of birth, zip code. But in my data warehouse, it could be last name, first name, zip code, date of birth. So it's same information, but it's in a different structure. So now I have to transform the data so that way it fits into this structure. So now when I'm doing this data transformation from one format to another file format, or another may not be even a file, but it's changing the structure or how my data is organized. So you have a source structure and you have a destination structure, or we call it as the source schema and a destination schema. And data transformation is nothing but telling you how the data in the source is changing to map map to that destination. You can simply say, okay, first name in source is equal to first name in this destination schema. What is the third element instead of the first one over there? And you can do that visual mapping as such. But that data transformation, that mapping logic is metadata as well. And that's where you hear a word. Whenever you talk about metadata, you hear a word called data lineage. The word lineage comes from genealogy, right? So you have your family tree. Okay, my mother's mother, what their family tree look like on the maternal side and on the paternal side. And you can create a genealogy tree and, who are your third cousins, who are your fifth cousins, and so on. But essentially, it gives you a trace back to, who were your great, great, great grandparents and so on, depending on the depth of the tree. Same concept. In a data lineage, you've got data in a report. Where did this data come from? It came from data warehouse. But this data in data warehouse, where did it came from? Well, it came from Salesforce CRM. Well, where does data came from Salesforce CRM? Well, it came through the Salesforce UI, or there was a application which was inserting data into Salesforce UI. So that data is moving across multiple systems. Your data lineage will be able to track and say what was the source system where that actual data was captured, what was the structure of the data where it was captured, and then the data was transformed. What was that data transformation logic? And then it was stored it in this place, and if there was any logic after that. But that data lineage is basically telling you in that report, at that end user report, where did this data come from? Because if there's any issue with it, an example, you've got a report, business says, how come the city name is 80% of the time it's blank, right? It's very important for us to know which city our customer is from. How come it is blank, right? So you'll say, well, I don't know, it's just there in the report. You can't say that. You'll say, okay, let me look at the data source. Where is the data source which the report is using to pull that data from? If the data source is data warehouse, well, then you need to know who wrote that data into that specific table, what is that process, or look at a metadata tool which has captured all that information and make it easier for you to trace that data lineage back to that source system. So one of the most common tools to do that is called Collibra, Collibra. So if you're a large organization, you want to manage your metadata, then you will use a tool like Collibra. They are expensive, but that's why I said large Fortune 10, Fortune 25 clients, they will use those tools because that cost is justified for them to manage and maintain that data. So a data catalog or a metadata management tool like Collibra, which is also a data catalog, which is cataloging all your data entities, what that data is, what is its metadata or what is its structure, where is that data stored, and what is the data lineage associated with it. So you can have a central repository where you are capturing and storing all that information. So metadata is structure of your table. It also includes data lineage, which shows how your data transformed when it's moving from one source to a destination system. Example of metadata could also be knowing if this table has PII or it has PCI. Okay. Any questions so far?
Mukesh, can you quickly summarize this last discussion? I could not follow completely actually.
Sure.
Though I understood a few points, but not fully.
No, I'm glad you asked, because if you haven't followed, I'm sure others haven't followed either. So I would rather you tell me, and I will be glad to explain again. Right. So metadata is of two types. One is technical metadata, and the other is business metadata. Business metadata means that metadata is used by the business to understand more about the data. Example of business metadata could be those conceptual data models, logical data models, and data dictionaries. And those are managed, typically those are managed and maintained by the data governance team, who has that business representation, so they can manage and own that data. Technical metadata is used by the IT or the engineering team. Example of technical metadata would be the data transformation logic, which would be used in an ETL tool. So an ETL tool will say, okay, this is the data in this source. Let's say in this case, CRM, Salesforce is my source system. Salesforce is sending it to the data warehouse. So source schema would be what's the data, the structure of the data in Salesforce. Because if you look at Salesforce customer, it will tell you exactly what all data attributes are there in the customer Salesforce data model. But I have defined my own customer in the data warehouse, because I'm getting customer from Salesforce, I'm getting my customer information from ERP, I'm getting my customer information from another MDM system, master data management system. They're all customer information, but the structure of it is not the same, it's different. So I need to standardize that structure of that customer information and store it in the data warehouse. But when I'm standardizing it, now the source CRM has a different definition of customer. My destination data warehouse has a different definition. The order of the columns could be swapped, or they would be adding few new fields which are there in one system but are not there in the other system. So in that case, I can just make it, that it's okay to not have a value for it. So my data warehouse data model will say, okay, you can have these three fields. Sometimes you may have a value, sometimes you may not have a value. It's okay if it doesn't have a value. But that metadata, which is saying how my data transforms from the source to the destination, how my data transforms from Salesforce to data warehouse, what was that transformation logic? That is metadata which IT needs to manage and support it as well. And if business is using that to trace it back, which field in this table, in this reporting dashboard or the reporting report, which field, this particular field, where did it originate from, which system provided that information, then in that case, I can use this data lineage to show all the traces of the data came across the system and be able to know where this data came from. And there are tools which will capture all this metadata, including business metadata and technical metadata, including storing the conceptual logical data model or linking it with with the data modeling tool and storing the data lineage so that you can have all the metadata in one place. And a data catalog is an example of a software product which is helping you manage that metadata in one place. And they're also nowadays called as data catalogs. Did I answer, Dinesh? Well, please say
Yeah.
no, because I want to make sure this is absolutely clear. I'm more than willing to explain this 5 times until you are convinced. Otherwise, it will defeat the purpose of this session. So is it making sense?
Yeah, Mukesh, I understood the concept now.
Okay. Has everyone else understood what's a data catalog? Because nowadays there are jobs related with, there's a new tool. These data catalogs, they are not that many in the market. And the problem is they don't have a good ecosystem of connectors to capture all that metadata. So there is one tool which is Colibra. It's very expensive. Not every company can afford to use it. And now Colibra has a lot of connectors because your data modeler is in a different tool. Your ETL tool, which is doing that data transformation from Salesforce, it's taking that data, transforming it, putting it into a data warehouse. That's done by an ETL tool. That is capturing the metadata. So I need a connector from my data catalog, which will connect to that ETL tool and say, okay, give me all that transformation logic. So then I can trace the data lineage. So the challenge was, these tools, they were very restrictive in terms of how and what metadata they capture. In the last 4, 5 years, I would say there's a lot of progress made because a lot of these data warehouse companies, they started providing these data catalog tools. Uh, Example being Databricks. Databricks has something called as a Unity catalog. So they start providing that tool. CDC tools like Click Replicate, they also provide a data catalog tool. So in the last 4 years, I've seen there's a lot of new products that have come in the market. But if I were to make a recommendation, of some organization asked me, what data catalog tool would you recommend? And I would ask them some questions, are you using Microsoft product? What ETL tools are you using? Or what data modeling tool are you using? And see if that data catalog has connectors to connect and capture that metadata. But usually nowadays, there's a very good product by Microsoft called Azure Purview. It's on the cloud, but it has a good, rich ecosystem of connectors to capture all metadata. I would strongly urge you to look at Azure Purview, Purview, to just get a feel of what data catalog is, what Azure Purview does. It'll be very insightful. Similarly, on AWS has its own offering called AWS Data Catalog. Take a look at that as well. And Colibra, you'll find YouTube videos on Colibra as well, just to get a sense and feel of what Colibra is or what a data catalog does. Most of these data catalog tools now they have what's called as a data crawler. as in when you create a new table, it will automatically recognize that a new table was created because they have this data crawler, which is constantly looking for new data that is being added. And this data crawler will then insert it into a data catalog and say, okay, this is the data I have. Who's the owner of this data? So, you can define a process and so on. But there's AI and ML being integrated into these tools. And there was another product along with Colibra, which has that data crawler capabilities or had those crawler capabilities before, is called Alation, Alation. So Tamru, in an interview, they will ask you about metadata. I want to make sure each of you can talk about metadata for 2 minutes. And you can say, well, I haven't worked with any data catalog tool, but I'm aware what organizations use. I'm aware what Colibra is, what Colibra does. I'm also aware what Alation is. I find organizations, there's a lot of interest in Azure Purview. And when it comes to metadata, metadata could be technical data, it could be business metadata. Business metadata is data models and data dictionaries, and IT or the technical metadata could include data transformation logic, which helps in data lineage. You can just repeat that and be able to talk for 2 minutes. They will know you know what you're talking about and you know what metadata is. Essentially, I summarize what I spoke for the previous one now. Any questions? Do you think you can talk about metadata for 2 minutes? Just 2 minutes? Or is it too much to ask? Or is it difficult? I
I
need your
think
feedback
we
because
can
then
at
I
least.
can add. Yeah.
Yeah, I think with this enough information, though, I think we have to understand some more details about these tools,
Yeah.
maybe some pros and cons about the different catalog tools available in the market, like as you mentioned. I think 2 minutes at least we can give some idea to the interviewer that we know what is
Yes.
data meta basically.
That's good enough. Yeah. So you don't want to be blindsided saying, "Oh, I have no idea what is metadata." You don't want to be silent. Even if you don't know everything about it, share what you know about it. Because 9 out of 10 times, the other candidates who you are competing with, they may not have that much awareness and what it is, what you do. So you will still stand out, even if you just speak for 2 minutes, because realistically, the other candidate may not be even able to talk about for 2 minutes. Okay. Let's do a quick time check. What's still a few minutes? Okay. Uh, so, what I'll just share how I keep myself updated with metadata. So usually, what I do is I'll watch some videos on Colibra, and that'll give me a good feel of what Colibra is, what Colibra does. I've read through a lot of Azure Purview documentation, watch the YouTube videos on Microsoft channel, and just get a feel of Purview. And after that analysis, I was able to conclude that Purview is a good product. I also looked at Unity Catalog, which is by Databricks, and I looked at Click Replicate Data Catalog. But essentially, the key finding after all the studies, which you can share with the interviewer, is that the challenge with adopting any data catalog tool is that first, you need to make sure that the information that is fed into a data catalog is updated and it's up to date, because most of the times you get the tool but the information is outdated because you're lacking a process to keep it relevant and updated. And if you don't have a process, then your tool is really not good enough, because you can spend thousands of dollars in putting that information in the tool, but after 6 months no one is updating it, then that information in that tool is useless. So it's always about people, process, technology. Data catalog is a technology tool, but you need to support it with the process to make sure the information it remains relevant. And the people should be aware of the tool, how to use it, and how to keep it updated. Many times organizations, they will use Irwin as a data modeler with limited write licenses, so only the data modelers can write it, but they have a very few limited read-only licenses. So only restricted users has access to that data model. And the reason is because these licenses are expensive, but it's counterproductive because not everyone has a good understanding of the data. And they're very stingy in terms of who gets access to those licenses because they are so expensive. So these are some of the practical challenges organizations have, which is collection of the metadata, integrating it with the data catalog tool to make sure it's relevant. That's why the trend is that with these data catalog tools, they're adding more connectors and more data crawling capabilities. So instead of you defining a process and saying, okay, I've added a new table and informing someone, these tools, they will automatically detect that a new table has been added and then say, okay, who's the owner of this table? And it will ask you questions. So that way it becomes a lot easier to manage and maintain your data in a data catalog. Any questions so far? Any thoughts? Uh, did you guys get a chance to read about Big Data Platform or have any questions about it? Okay. Uh, Next session, we'll probably start looking at more of a life cycle of data. What is life cycle management of data, and what are some of these ILM tools, which is information lifecycle management. Very few organizations use it, but I just want you to be aware of them, what they are, what its purpose, and then we'll touch upon what all we discuss the definition of data architecture, which is managing the design of your data from production, where it is produced, all the way to consumption. So we discussed metadata, how that data is stored in a data warehouse, what is a data lake, and so on. But we'll go through that circle again. For those who are very interested, there's something called as DAMA, DAMA, and it's nothing but a data architecture. Some are, I don't remember the full form, but essentially it's a group which defines the best practices related with data. Usually that membership is expensive, but I have a copy of that book. I'll just have to search for it. For those who are interested, I would be glad to share that as well. But essentially, it covers everything, anything you need to know about data. So we'll go through that Damar circle, which there's a graphic for it, to make sure that we've touched upon things that are relevant from a data architecture perspective. And we'll cover a little bit more theory, and after that, it'll be just case studies, brainstorming, interview practice. So that way, when you take up a job as a data architect or when you are giving an interview, you'll know what it is. The more case studies we do, uh, the more confident you'll feel, and you'll be able to apply all the theory that we've done in the past few weeks into practice to see, why it is relevant, how it is relevant. And we'll do actual look at some of the data models, look at what a data catalog is, some of the analysis, so on. So we'll get into a little bit more practical aspect of it. A few weeks back, I'd asked you to download any database, whether it's MySQL or so on. Does anyone have any challenges with it? Or I don't know if any of you got a chance to look at MySQL, because one of the other things we want to do is get some hands-on practical experience with inserting data in an RDBMS, writing a simple one or two SQL queries, because then you can technically say, yes, you know SQL, and never claim to be an expert in it, because that's really not your job. But at least you know what SQL is. So I would strongly urge you to download MySQL. If anyone has already done it, please let us know. Or if you've not done it, please try to do it this week so we can catch up on those activities. And meanwhile, if you come across any topics and know what to do, we'll discuss that as well. I think Tapesh, you wanted to talk about data integration. So I think next week, we'll talk more about data integration. But essentially, once you understand how data is flowing from source to different destination, what are the different data integration tools, when to use which tool, we can cover all of that as well.
Sure, Krish. Sure. Thank you.
But meanwhile, start taking a look at different job boards and start creating a CV. Because once you start creating it, you'll be like, oh, what does this mean? Or what is this buzzword? Most probably we've already covered it, but if not, we'll, as a team during this session, we'll take a look at some of the job postings and we'll make sure that we've covered all the buzzwords and keywords in the session. That way, when you go for these interviews, you will see it'll be a very different interview because they will appreciate you for the depth and the breadth of knowledge you have. And the case studies will give you that depth. And this theory will give you the breadth. So you know what is metadata, you know what's cloud data warehousing, you know a little bit about cloud. So it'll be fun. So we'll go through that exercise as well. Okay. Any other questions? Otherwise, we will do a quick round of mind enlightenment or mind empowerment technique. Okay. So we'll conduct a mind enlightenment technique because enlightenment is empowerment as well. It's what enlightenment is basically knowledge, right? If I ask you to drive in the dark with no headlights on, and if it's a curvy road, what will happen? Accident is bound to happen because there's not enough light, there's not enough information on how to navigate. It will result in accident. Same thing with life. If you don't have the knowledge on how to navigate through different challenges in life, it will result in an accident. So knowledge is empowerment. So what is the knowledge? There are a few simple basic techniques that if you understand, it will not only help you to navigate through all the unknowns and the challenges in life, but it will allow you to safely navigate them and make sure you reach your destination. Some of the tricks or some of the tips that we've covered in the past is when you're driving, you always need to focus what's on the forward. You need that information and wisdom to move forward. You cannot look in the past and drive forward. It doesn't work, right? So if you're learning how to drive, you will see that your rear view mirror is very small because it's there because you want to learn from the past to get better. But if you have to drive forward, you need the windshield. You need to look forward. You can't drive forward by looking in the rear view mirror. So step number one, make sure you're looking forward. Second is if you need to reach a destination, you need to know what is your destination. You need to have a goal in your life. You need to have a specific goal. If you don't have a goal, you will be nothing but randomly moving from one task to the other, and you will tire yourself out. And essentially, you will be driving around, but you're coming back to the same place because you do not have a destination. So it's very important that you're moving forward in life. This is a new year that started. I hope you've created goals for yourself. You're not looking in the past where you're not looking at your past failures to say, well, I usually don't clear the interview, or, I don't know what it is. It's so nerve wracking. I don't know what to do. There are so many difficult questions and blah, blah, blah. Put a full stop to that negative line of thinking. It doesn't do good to you. It doesn't do good to anyone. It is a waste of time, wasteful activity which will drain your energy. So it's important to stay focused on your goal. Another way to stay motivated is make sure that goal is very clear and clearly visible to you in terms of if you were to, let's say, the goal could be very simple. Let's say your goal could be getting a job as a data architect. what would it feel like when you get that job? Imagine that. That will give you a burst of positive energy. See yourself being in that, or achieving that whatever goal you set yourself. Make sure you see it with so much clarity that you will become what you think, right? That's how the mind works. So feed it with a goal, see it with so much clarity, you know, and be able to then drive forward. And then when you are driving, you have milestones on the road. That milestone will give you a measurement of, how far you are away from the destination. So similarly, like how we have project plans where we are measuring milestones and seeing how far we are from our destination, you need to have milestones in your life as well to know how far are you from your goal. Are you 10 miles away from it, or are you still 100 miles away from it? How would you measure your incremental success? Because that will keep you motivated as well. So that way, you've got that positive feedback loop where you are progressing further in life, where you are going in the right direction. So those milestones, those key markers will help you to move forward. And most important, right? We've talked about that, you always need a navigator in life. It makes it a lot easier. Uh, and so having that supreme intelligence become your navigator is the best insurance policy, because we are limited by our wisdom. But when we have our companion, someone who's super intelligent, then it's naturally bound to be, you would be intelligent as self, because as the company, so the color. And the best way to build that relationship and have that companion is, it is the ego which thinks, our alter ego which thinks, I'm working hard, I'm doing all this, and we associate our failure with our hard work and everything. But in reality, this is a world drama. Everything is predestined. What is not predestined is your effort. The outcome of it is never in your hands. So success is not, defined by the outcome of the effort, but success is purely sheerly defined by your effort. Whatever the outcome is, that is beyond your control. You're going for an interview. You might give the best interview of your life, yet you may not get the job. Don't even think about it, why you didn't get it. You may do some postmortem to see how you can do better, but going into the excessive details, why you didn't get it and so on, is a waste of time, because this is how the world operates, right? You focus only on your effort. The outcome is never in your hands. So one might say, well, then why put the effort if the outcome is never in your hands? The reason is because you really don't know the outcome, right? Your effort will prevail. So always do your best, put in your best effort. But once you done putting the best effort, then don't waste your time and energy anticipating the outcome. An example is, you give a certification exam. Put in your best effort to give that certification exam. Prepare as much as you can to give the exam. The moment that exam is over, don't spend 3 hours thinking about, oh, is this right answer or is this wrong? Oh, I should have done that. Did I check that or not? That all is wasteful thinking, because you've already given the exam. The outcome is based on that exam now. You overthinking about it makes no difference. So it's a waste of time. So it's important that you use your time and energy efficiently. And again, the way the world operates is that if you use all that time and energy for yourself, eventually you will drain out. But in the world of in the physics for the spirituality, the more you give, the more you will get, right? We discussed in one of our sessions. In physical world, if you give money, yes, you are depleted by that amount in your account. But if you're giving away knowledge, if you're giving away peace, happiness, you're giving it away, but you're actually getting it more. So the laws of physics for spirituality are totally inverted. So understand that, accept it, right? And keep moving forward. And many times we discuss this as well, what to give. There are a lot of things that you can give. You can give your time, your energy, your wisdom, your knowledge. You can share peace, you can share love. There's too much to give. You don't have to restrict or limit yourself to giving money. That can only do limited good for a limited amount of time for limited people. Whereas if you're giving your good wishes and spreading vibrations of peace, love, happiness, those go far beyond, what you think you can achieve with them. And specifically, this is how the world operates. Another mind enlightenment technique is, how do we communicate with God? Does God speak English, Hindi, Malayalam, or which language does God speak? And the answer is, God speaks the language of love. It doesn't have to be in words. Your pure thought of longing and love, wisdom, that reaches to the supreme intelligence or the supreme soul, because that's how it operates. So you don't have to specifically repeat any mantra or anything, because the greatest mantra of all, there are a lot of Vedic scriptures, a lot of religions, especially in Hinduism, there are a lot of mantras, and there's a belief that when you repeat that mantras, you gain. But what is the most powerful mantra of all? And what we've learned through supreme intelligence is man mana bhava. You are a soul, and connect with the supreme soul, just as a soul would connect and talk with another soul. That is the greatest mantra of all, because it makes you realize that you are not your alter ego. You are not who you see in the mirror. You are not who's limited by the limits of this body, but you are who's infinite. You are who is the powerful soul. And your true relationship, which is constant, does not change with time, is your relationship with the Supreme Soul. So that's why that is the greatest mantra of all the scriptures, because it gives you a true identity of yourself and helps you build a stronger relationship with the Supreme Soul. With that, we can conclude this session for today. Again, Happy New Year to all of you. Which I hope you've got your goals defined, and wish you all the best for your goals for this year. Thank you very much, all of you.
Thank you,
Very
Dr.
much. Thanks.